For inverse tangent, I'm going to start here by rewriting this as y equals tangent of x to match how I wrote this in for my sine and cosine graphs. And then I have y equals inverse tangent of x. Let's start by drawing the graph. Vertical asymptotes will become horizontal asymptotes since x and y have switched places. They still occur at 270, 90, negative 90, and negative 270, but they're going across the y-axis instead of across the x-axis. The zeros are still in the same place, but they're on the same angles, but they're on the y-axis now instead of the x-axis. Now, the trickier part is putting the 45-degree angles in the proper spot. So you'll see that we have places where tangent equals positive 1 and places where tangent equals negative 1. And those are all at 45-degree angles. Because if we think about our tangent values, remember, if you have a 45, 45, 90 triangle, this is going to be the opposite and adjacent sides will both be 1. If we're in quadrant 2, the opposite side's still positive 1, but the adjacent side's negative 1. In quadrant 3, they're both negative. In quadrant 4, the opposite side is negative and the adjacent side's positive. So this makes sine positive in quadrants 1 and 3 and negative in quadrants 2 and 4. So I put those 45-degree angles with the 45-degree reference angles down here in this list, and I have 45 positive 1, and that would correspond to this point right here, 45 1. 135 negative 1, that would be this point down here, 135 negative 1. 225 positive 1, that would be this point here, and 315 negative 1, that would be this point here. And then notice we also have a place over here. This would be negative 45 negative 1. So we have an odd function again where opposite inputs give me opposite outputs. Now let's plot a few of these points here. Positive 45, positive 1 becomes positive 1, positive 45, which is right here. Negative 1, negative 45, negative 1 becomes negative 1, negative 45 down here. So the curve looks like this in the middle. And all of these curves are going to look very similar, just kind of like this. And I'm not being as particular about where the 45-degree angles go on the other ones, just kind of get the basic shape here. Now, it would make sense, based on what we've done with sine and cosine and their inverse functions, that we would use this center section of the graph, because the center section gives us angles for positive trig values and angles for negative trig values, and it limits it to one angle per trig value. So if we just look at this center section here, we would see, for example, here's the point 145 degrees, and here's the point negative 1, negative 45. So that means if we were doing inverse tangent of 1, we should expect to get positive 45, and inverse tangent of negative 1, we should expect to get negative 45 and not 135. So let's double check to see if we do get plus or minus 45 for inverse tangent of 1 and negative 1. So tangent of 45, 1. Inverse tangent of 1, 45, as expected. Tangent of 135, negative 1. Inverse tangent of negative 1, as expected, negative 45, not 135. So, like sine, we're going to be using positive and negative angles for our positive and negative trig values. So 45, negative 45, then obviously 225 is going to revert back to quadrant 1, 45, and 315 to the negative angle in quadrant 4. Now, interestingly enough, unlike sine and cosine, we have an infinite range of trig values. Trig values don't stop at 1 and negative 1. They go on forever in both directions. And So we could put in bigger values into our tangent function, bigger values than +1 or -1. So for example, I could do inverse tangent of 4, and I picked that because you can see that on the graph, inverse tangent of -4. I could even do something as big as inverse tangent of 1,000. So let's just double check and see what happens when we do these. So if I do inverse tangent of 4, you can see, oh, I didn't do Control Enter. Your calculator sometimes gives you this crazy equivalent form that isn't terribly useful. Inverse tangent of 4, about 75.9 degrees. Inverse tangent of -4, and I'll do a Control Enter this time, -75. And let's try that inverse tangent of 1,000. Control Enter, 89.9 degrees. Now notice, tangent is opposite over hypotenuse. So if I have a very small adjacent side and a very big opposite side, so here's my right triangle, and this is 1 and this is 1,000, I'm going to get, this is going to correspond to an angle that's very close to 90 degrees. So this fits what we said here. If I do 4, I get an angle really close to about 75 degrees, -4 about -75, and the farther I get from 0, the closer that my my angle is going to get to either +90 or -90. So this turned out to be about 75.9 degrees, about -75.9 degrees, and this turned out to be 89.9 degrees, very close to 90. So let's look at the domain and range of the tangent graph. The domain, which are the angles, can be all real numbers except where the asymptotes are. And so we're going to say x is not equal to 90 degrees, that's where one asymptote is, plus or minus 180n, because all the asymptotes are 180 degrees apart. In other words, not the asymptotes, not the asymptote values. So all real numbers except those where those asymptotes are. The range, or the trig values, are -infinity to infinity. We can have any possible trig value. So the domain of the inverse function, the trig values can be any real number. So these are the trig values. These are the trig values. These are the angles. Now the range, of course, would comprise only the principal angles for this trig function, and the principal angles are from -90 to 90 using a soft bracket, endpoints not included, because because tangent of 90 and tangent of -90 are undefined. In radians, that would be -π/2 to π/2, or -1.57 to 1.57. The principal angle, remember, is the one angle that I get when taking the inverse trig function of a particular trig value. The principal angle is the angle closest to 0 that has that particular trig value.